So this is the last set of slides for week 12, and now of course we're going to do the last condition. We did confounding, we did mediation, now we're going to do effect modification, otherwise known as interaction. And also with interaction, you will be presenting a different measure of association when you have effect modification present. When you have a confounding present, you report the adjusted Mantel-Hansel odds ratio. When you have mediation present, you report the crude odds ratio. When you have effect modification present, I'm going to teach you that you're going to have to report the Stratton-specific odds ratios. So effect modification is when you have, it's a condition where the strength of the association between the exposure and disease actually differs, I should say differs, across different categories of a third variable. It just means that, say you have gender as the third variable, the association between exposure and disease will differ between men and women. It'll differ between the two groups of the third variable, or age, young age versus old age. We will only see an association for males between exposure and disease, or age. You will only see an association between those who are with those who are younger between exposure and disease, or it can differ depending on the level of a third variable. And so we're going to tell you what that means in a second. When the risk of disease in the presence of two exposures differs from the risk expected to result from the individual effect of an exposure. That's another way of saying it. I think there are other ways to learn it, but we wrote that down. We write things down. We write different ways to understand it down, and eventually people, will figure out which way is best for them to understand it. So here's an illustration of exactly what I mean, which should help. Effect modification is the extent to which disease D, this disease, is related to exposure will actually depend on whether B is present or not. So if B is present, then the exposure has a strong association with disease. If B is absent, it won't have a strong association. The exposure won't have a strong association with disease. So we could say that B is, say, a gene. If the certain gene is present, then the exposure will be associated to the disease. It'll have a strong association. If the gene is not present, then the exposure will not be associated with the disease as strongly, or not at all. So what's the effect modifier in this case? It's gene. The presence of the gene is making this association stronger. When the gene is not present, there's a weaker association between the exposure and disease, or no association at all. So the odds ratio, the association of deployment in Iraq with depression of members of the military by gender. So here the difference is in females, the odds ratio of depression is much higher than it is among males. Here's another example too that usually helps students. Here we have different outcomes. You can only focus on one if you want, just to simplify things for you. If you look at the prevalence of, say, this one outcome on exposure as to where you live, right? There's really no difference between urban and rural, right, on the prevalence of PTSD. They have this almost equivalent prevalence, right? Even here on this side they do. It's almost equivalent in each example. But where's the difference? The difference is if you compare victims and non-victims. Then you see within rural and urban and rural. So the living location is the exposure, right? And the outcome, say we're just choosing one outcome, is PTSD. Here's the difference. 12-ish% if you're a victim of prevalence of PTSD, versus if you're a non-victim, it is only 2%. And the same thing for delinquency. It's much higher among victims than non-victims. There's a small change in between rural and urban, in between the exposure and disease, in between the two exposure categories, but the real difference is between this victim versus non-victim category, and that's the effect modified. That's how it would look. So how do we assess for effect modification? The good news for you guys is that it's the same way that you would assess for mediation and confounding, but you would see a different result in this case. Remember, confounding and mediation will look the same, the data. Effect modification will not look the same as confounding. It will not look the same as mediation, but you follow the same steps almost identically. You start off with the crude. So the crude association between the exposure and disease. Say we're looking at poor nutrition and TB, tuberculosis. So you do the usual crude odds ratio. The crude odds ratio is what we've been calculating all along. Between poor nutrition, the main exposure, main disease, TB, the odds ratio is 3.6. Then we do this job-specific odds ratio, just like we did in Lab 1 for confounding. And now we get an odds ratio for those people who have a mycobacterium. No mycobacterium present. Negative. So their odds ratio is 0.95. Then we do the same stratum-specific odds ratio now for the mycobacterium present, and that odds ratio is 6.6. These two are our stratum-specific odds ratios. What I did here is exactly what I did in Lab 1. And the previous lab from last week regarding confounding. I looked at the main exposure and disease association between poor nutrition and TB, but I only did it among those people who did not have the mycobacterium. Mycobacterium is the effect modifier. Then I looked at the main exposure and disease association between poor nutrition and TB, but I looked at it only among those people who had the mycobacterium. So here, no mycobacterium, I got 0.95 my odds ratio. Here, mycobacterium present, my odds ratio is 6.6. So now I have two stratum-specific odds ratios and I have a crude odds ratio. The crude odds ratio is taking everybody in your sample. Here I divided them, I stratified them by the presence or absence of the mycobacterium, which we think is the effect modifier. Now I want you to look at the stratum-specific odds ratios, because remember, with confounding and mediation, they will be similar to each other. Are these two similar to each other? They're not. Having someone with an odds of 6.6 and 0.95, they're completely different. So here's an indication that this mycobacterium variable may be an effect modifier, because when the stratum-specific odds ratios are different from each other, the variable is most likely an effect modifier. How different is different? That's what I'm going to teach you next. Here's a summary of what I just said. Stratum-specific odds ratios are different from each other, 0.95 versus 6.6, so it's most likely not a confounder mediator. But how different is different? Is this difference just happening by chance, or is it truly different from each other? So you have to do a statistical test, the very last thing you have to do, to make sure if they're truly different from each other. If they're truly different from each other, then they're going to be effect modifier. This mycobacterium will be an effect modifier. So how do you do this? Very easy. This will be in the lab for this week. You run something called the Breslow Day Test. All you have to do is click on a little field, and I will show you how to do in a lab. You must watch the lab. And that Breslow Day Test will give you a p-value. And I'll show you in the lab where you find the p-value on the output. And all the p-value will tell you is, if the p-value is less than 0.05, that means a statistically significant difference between those two stratum-specific odds ratios. In other words, here it is. Here's the results of the p-value. You're going to see this if you look at the lab. You must look at the lab. Here's where you're going to find the p-value. It's going to look exactly like this. It's going to be labeled Breslow Day. It's going to be over here. And if this number is less than 0.05, that means that the stratum-specific odds ratios that you just calculated over here are truly statistically significantly different from each other. And if they are different from each other, that's a sign that you have effect modification, that the mycobacterium over here is actually an effect modifier in between the relationship between poor nutrition and TB. Okay, if the p-value is less than 0.05, you likely have an effect modifier. If it isn't, then it's not an effect modifier. That doesn't mean it's a confounder or a mediator. It may not be anything in the relationships. You can't make that assumption. So that's how we do it. So if this is less than 0.05, we conclude that the associations differ significantly by strata. Those two stratum-specific odds ratios are statistically significantly different from each other, and therefore we say that we have effect modification. Here's another example. Say main exposure is aspirin, main disease is heart attack. Aspirin people think that taking aspirin prevents heart attacks. How about we put in a third variable called gender? And it's possible that we may find in the past this was true. I don't know if it's still true now, if the findings have been refuted, but that aspirin protects heart attacks only among men, doesn't as much among women. So effect modifiers, gender in this example. Most commonly, the effect modifiers are like a gene or gender because it'll depend on the level of that third variable, the level of the third variable or the grouping of the third variable. For example, it's only present among the level of men in that third variable and not women. So aspirin is associated with a lower risk of heart attacks, but only in men and not in women. We say then that the relationship between aspirin and heart attacks differs by gender because the association is different by sex. We can also say that there is an interaction between sex and aspirin in the association of aspirin with heart disease. That's just the way that we interpret it. You can also, just like we did with confounding and mediation, I'm going to go through this quickly because you're not going to see there's a lot on the test, but you can have complete effect modification and partial effect modification. Here, the exposure and disease would be associated with the presence of a third variable, but not associated without it. Okay, so the odds ratio for A would be 3. The odds ratio for A without B would be 1, which means that there's no association. Say, and this is what I mean here. Example, if that I looked at the aspirin with heart attacks, and this would be 1. Okay, there would be no association, right? Because 1 means no association. But if it's here, this would be an association if men was present. So that's what I mean by that. There could be a partial association effect modification, which means the exposure of disease exists across all levels of a third variable, but the magnitude of the association differs. So for example, I could have aspirin being protective against heart attacks among men by say, 0.03, but for women it's just 0.8. So 0.8 is less strong because it's closer to 1 than 0.03. 0.03 is really protective. It's further away from 1. So there's still a finding here. It's still protective among women. We got 0.8, but it's stronger, less further away from the null value of 1, more protective among men. But there's still a finding here. This is not 1. So that would be partial confounder, partial effect modifier. What do you report when there's effect modification? Well, the finding is the fact that these two Stroum-specific odds ratios are different. That's the most important part. So what are you going to report? You're going to report the Stroum-specific odds ratios. Just like with confounding, you report the adjusted Mantel-Hansel OR. With mediators, you report the accrued, and with Stroum-specific, the finding is in the Stroum-specific, with effect modification, the Stroum-specific, that's where the finding is, so that's where you report it. So the Stroum-specific odds ratios or risk ratio should be presented and not the adjusted, because the strength of the association depends on the presence of the third variable. So that's how that works. And you will absolutely see this in the lab for this week. I will run through this entire thing and you'll see exactly how this works. It will be very, very helpful to you. So here's just a summary. Confounding is a common cause of exposure and disease. It's biasing the association, so you adjust for confounding to isolate the true association and you report the adjusted Mantel-Hansel OR. The mediator is other factors on the causal pathway between the exposure and disease. It's caused by the exposure and then it causes the disease. It's on the causal pathway. You report the crude association. Effect modification, the association between the exposure and disease differs by the level of some third factor. Male, female, young or old, a gene, presence or absence of the gene, a mycobacterium, presence or absence. So therefore you report the Stroum-specific measures of association across that third variable. So what do you think the following third variables might be confounders? So alcohol intake and heart disease, cholesterol level. Could that be, what do you think that is? Could that be a confounder? Could it be a mediator? we're not going to put you in so much of a situation where we're going to give you a lot of examples like this and ask you to tell the difference. Um, Smoking and asbestos at work, exposure to asbestos at work and lung cancer. Smoking doesn't lead you to have asbestos at work. Um, this could be this could possibly be an effect modifier because smoking leads to lung cancer, but if you also have asbestos at work, the asbestos exposure at work, you might have an even stronger association between smoking and lung cancer. So, sort of like that's how you have to think about it. We're not going to test you like this. We're going to mostly give you um, think about like give you very obvious examples and then also have you look at the data a little bit and decide, even though there's some indecision in the department about whether looking at the data is helpful. We've always taught students that it's important to look at the data, but now there's sort of a paradigm shift, and some epidemiologists feel that you shouldn't look at the data. But we're still teaching you how to look at the data in this class, and we're going to rely on it uh, for the most part in the homeworks and on the exam. So I don't want you to feel like you're going to have to look at these and decide, because as you saw on the slide, it's very difficult to tell between a mediator and effect and a confounder. Epidemiologists can't tell the difference, so we don't expect students um, to uh, to tell the difference. Um, so just know that that could be the case. So here are a couple of just a nice summary sheet for you on everything I just said, which I'm hoping this will also help you. I'm not going to repeat everything because this is just a summary of everything I said. So you could go through this. It's all summarized here on one page. And you can let me know if you have questions about this. And that's the end of this lecture.